There we go. All right, where are we? We're back. And we're back. Good evening. So, back from walking the dog. And going to pick up where we left off with this. So, on the downside, I now have almost no memory of what I wrote earlier. On the plus side, I've had some time to think about it, so that's nice. Definitely, I feel like I'm definitely overthinking things. Oh, excuse me, I'm also tired now, so maybe this won't work out too well. So let's take this example, right? We've got something like this, right? And really, what does that boil down to? It boils down to one of these and one of those. And what does that mean? Like, what do I want to do here? I guess I want to add these up, and then I want to multiply these. And what I really want to do is I want to collapse them, right? So I want to be like, I want to collapse all the pluses first because that has priority. So I'll go through and I'll be like, oh, hey, here's an addition, so I can make that happen. And then when I'm out of additions, I can go through and do all the multiplications and be like, oh, here's a multiplication. Here's how that evaluates. And so I'm going to do, I guess there's a third step too, which this is sort of hinting at, right? Where I've got this, and I'm going to go through first, and I'm going to do all the arrays. So I'm just going to cycle through every element in the array, and I'll find all the arrays, and I'll evaluate the arrays. So, I'll evaluate that to 56, and then what I can do is I can go through and I can do the pluses, and then I can go through and I can do the stars, or the multiplications. So that's really what I want to do. So I guess that's what I want to do with evaluate line, every line is going to be an array. So this is the array. And you know what? Let's just get rid of that whole thing. Let's get rid of evaluate line, and we'll just redo it. So we've got array, and then what I want to do is I want to go through and for element in array. So actually, this doesn't need to be. This can just be an array. For element in array, what I want to do when when object is type of array. Oop, there you go. What I want to do is I want to evaluate element index. So I want to say array index equals evaluate L. So that should override it. So let's just and then at the end I'll return array. So let's take a look at this. This should always be an array. Always be an array. Okay, so let's just test it down here and see if. Okay, so we'll get rid of all this crap. Whoops. There we go. Okay, so evaluate line. Let's evaluate one of these. Cool. And let's log the results of that. So what do we got? It did not do what I was hoping it to do. So array index equals evaluate line element for element in index, for element index in array when object is type of element. So I was looking for okay, so let's do this. For L index in array when object is type of element. And let's log element. Okay, so it did find the element. And, oh, it can't evaluate it because there's nothing to evaluate. Right, okay. So at least it's doing it, and it was just putting it back. So what we actually want to do is we want to move on and say, okay, we want to go through the array now, and we want to find out where all the pluses. We want plus priorities. So for in length -2, and okay, whoops, here we go. So basically, we're going to go through and we're going to get the first we're going to get the first three. We're going to say left op right equals array for index up to index +2. Okay, and let's log those and just see if, oops, let's log those and see if we're getting what we're expecting to get. Yeah, okay, cool. And neat. Okay, so we want that when, or you know what we could do is we could, it always starts with 1, so let's go to 1 and array -2 by 3. No. 0. Interesting. Look at that. We got none defined. Okay. Interesting. Yeah, I think I'm overthinking it. Okay. Okay. So we got that, and what we want to do is we want to solve everything. So okay. So ret equals that. Yeah, I guess what we're going to have to do is we're going to have to have a counter. We're going to have like I equals 0, and then for I in that, or I guess we'll have to say while I is less than rate.length. Rate.length. And okay, we'll say if op and right. So what do we need to do here? So we're evaluating the line. We're going through and we're evaluating. So we're getting all the arrays done first. Now what we're doing is we're getting all the pluses. So this is evaluate pluses. Additions. There you go. So, okay, so if op and right, then what we want to do is we want to say array at I is equal to left plus right. Yeah, and what have I, oh, so I've already evaluated those, and we've updated array. Okay, so array I equals left plus right. And then what we'll want to do is we'll want to continue and op is plus. Okay, then we'll want to continue. Else we will want to move forward. I plus equals 1. Okay, so let's see what we get out of this. So this gives us a bunch of things left. So this is evaluate line. So that would give us 3 plus 9. So we should have a 12 in there somewhere. I guess we don't. Log evaluate. What else are we logging? Oh, we're logging these. Okay. So this is giving us 1, 2. Oh, array at I equals left plus right. So let's log left op right at every step. Undefined, undefined, undefined. Okay. Oh, index. So these are now I. It's doing a lot of things. Okay. So wow. Okay. No, this is just. So we start with 8 plus 6, which is these ones. Okay, and then that. Oh, I see. Right. Okay, so we're setting that, and then what we want to do is actually we want to say array equals array I, or no, we want array to equal left plus right. Right, we want to slice. So left up right. So we're pulling out the middle of array 2, and then right, we're gonna want to do this like this, basically this thing that we were doing right before, which maybe we're not doing anymore, where we were creating a new array. Right, we want array up until I. Okay, oops, come back. Oh, hey, it's down. No, yeah, it's here, this tokens thing right here. That's what we want to do basically, but up here. Okay, okay, so we're gonna say array equals array up to and not including I, and then from I plus 2 on, and then we want it to be left plus right in the middle. So let's see if that works. No, 8 plus 6. Oh, tokens. Right. Okay, so that's totally not what I was thinking. Let's try that. No. Okay, so we're logging left op right. No, so 3 plus 9, yes, so that should give us 12. So let's log array there. So that logs just 1, 2, 3, 4. Okay. So why is this so difficult for me today? That's a good question. I don't know. Is this a really difficult problem, or am I sleepy? I guess, you know what, it makes sense that it would be difficult, because it is like day 18. Okay, so we're left, up, right. Okay. Left up right is left up right, so that's 12, 9, and star. So why is that the case? Where is it getting that from? Oh, okay, right. So it's 8 plus 6, so it becomes 14. Aha, so up to I. No. Up to and not including I? Plus 1? No, wait, this is right. Up to I. Okay, so that 8 plus 6, 14. I think I have these. Yeah, up to and not including I is what we want, right? Okay, so then that replaces 6 with 4. Yeah, so that would replace 8 plus 6 with 14. Yeah, okay, so hold on. We get 1 in, and then we get 2 in. Oh, and we have to account for the sign node. So yeah, so left up, right? Okay, so that's I plus 1, and then we want I plus 3, 2, I plus 2 on. That's up to and not including I plus 1. Okay, so what do we got? Nope, still wrong. So that becomes 14, 14. Hey, what are we doing? Okay, so let's say I've got left, up, right is 8 plus 6, and that's the first 3 things here. 8 plus 6, and I want to replace these 3. So I want to replace the 0th offset up to the 2nd offset. So that would make, oh, so we want 3, okay, with 14. So I guess what's this? Let's log that. We'll log left plus right, and we'll log that. Okay, so we got 14. Up to, oh, it should be just up to I guess. So that should give us empty array 14 and then star 4. And then for some reason, oh yeah, because this I here, I. So up to not including I, plus left and right, plus I3. Okay, so cool. So that gives us 14 times 4, which is what we want here. Okay, and then, okay, so and we haven't handled that yet because we are not evaluating, oops. We're not evaluating multiplications yet. Okay, log. Oh wow, that was wrong too. There we go. Okay, cool. So this is additions, and then we want to evaluate multiplications. So if op is star, that left, right. Cool. And then what we're going to be left with is an array of 1. So that's log r 56, and I think 56 is that what we're going for in this case? Probably not. Oh, okay, so that would be 14, yeah, 14 times 4 is 56, perfect. Okay, so we're going to return the only element left of array is what we're going to do. And that's going to be evaluate line. So evaluate line, it's going to go through, it's going to evaluate the parens, going to evaluate the additions because they're first, it's going to evaluate the multiplications because that's last. And now if we try that, we get this, which where was that? Assert. Is this even in the file anywhere? No, it's not. So this has a different answer. 7. Oh, because it's a substring of that. Okay. So let's see if that's true. It's not. Okay, so let's evaluate line 5. Well, let's tokenize. Yeah. Let's tokenize that and see what we get. So 5 times 9 times all that stuff. And what happens if we evaluate that? Log evaluate that. It breaks. Text split is not a function. Why did evaluate? Oh, evaluate line. Evaluate line. 66, 90, 60. Oh. Okay. So maybe evaluate is broken. So we're evaluating. Oh, because we changed this to just take an array. That's why. Tokenize. How many places in here do I have tokenize? Tokenize. Good. So everyone's expecting. What about evaluate line? That's where I need to check. Evaluate line element. Okay. Evaluate line. Good. Okay. I think we're good now. So let's try it. Let's see if all these assertions are now true. Boop. Yep, beautiful. And we will go down to the last assertion, and it works. Beautiful. And then we want to evaluate the last of it. Okay, and then if this gives us a number that works, then we can go on to the refactoring step. Refactoring. Hooray! It worked. Okay, cool. So the refactoring step. One thing you'll notice is that these two blocks of code are extremely similar. I wonder, like, what we could do. We could clean it up. And in fact, that is, I don't know if it's going to be much better, honestly. So what if we have add line and then mult line, and they both take an array. Oops. So what would this mult line an array be like? And then mult line. Because really the only thing that's different is that they do something slightly different, right? So, and then we'll do like operate the line equals, and then that takes like add or multiply, but how are we going to pass that in? Is a symbol and then a valid? I don't know. What about JavaScript math? Are there methods we can call like add or multiply? Let's take a look. I mean, there's floor, round, seal, add, no, sum, nope, the result 32-bit integer multiplication, but there's no just like multiply. Yeah, okay. So like, yeah, if we did do that, what we'd have to do is we would, I guess what we could do is we could clean it up just a little bit by saying, you know, symbol add, but then we'd actually need to pass in a function. So the function would be like a plus b, and then we could have multiply a times b, and then we could do, you know, symbol function each do. Let's do that. Okay, so for sim func in or of. We could do that. Yeah, but then I mean, yeah, it's just gonna be more confusing, honestly. I think it actually makes sense just to leave it the fuck alone. It's not great code to begin with, but like trying to meta could only make it worse. So I'm not going to do that. I'm just going to leave notes. I feel like that's an option, right? The option is either get real complex in the code or leave a comment and be like, yeah, I know this duplicates, but it's not worth it. So let's leave some comments instead. We'll spend our energy wisely. Return the last remaining value. The answer. Okay, so evaluate additions. Yes, it's similar. And this is evaluate parens. Okay. So we got tokenize. I wonder if we could actually just do like a JSON evaluate, find and replace on these things. Maybe, I don't know. I think I try that and it didn't work. Why did that not work? Can I just do that? I think I can. Let's see, did we get the same answer? 9217? Yeah, we did. Okay, oops. Okay, so subtree and string equals tokenized string, and then we're gonna return tree string, and then we'll return tree and not string. So this is kind of a shitty code smell that I don't like, where tokenized returns two different values depending on whether it was called by tokenize or not. Return just the tree if there's no remainder. What we could also do is, I mean, a tree is just an object, or I guess it's an array. What we could do is we could return tree with a property called like leftovers. Yeah, let's see what that's like, because then at least it's still an array. We've just tacked a property onto it. Okay, so then that would be subtree equals tokenized string. And then what we would do is we would, okay, so we would say tree dot remainder equals string, and then return tree. And then what we would do is say str equals subtree dot remainder, and then we're just gonna push subtree. I wonder if that'll work. It does. Okay, cool. And then we don't need to screw around with returning several things. We can return just an array, like an array of things with this accessor, this dot accessor on it, right? Because like, really, what is that like? That's here, log. So we're gonna have r equals 1 2 3, and we can say r dot cool, or r dot Kieran equals cool, and then log r. What does this give us? R is not defined. Have just one RR. So we get Kieran cool, but r dot length is still, whoops, is still 3. So I mean, it just adds a text property, but it's still an array, which is super fucked, and I like it. So I mean, would I want to depend on this in, like, you know, high stakes production environment? Maybe not. But in this case, I'm okay with it. Cool. So we got tokenize, break unless, so C in string. So what is C? Character. So the first character of the string, and this is really like head and tail, isn't it? Or head and string, but C is fine. Continue of C is that. I don't know if we need that. We really just don't. Okay. Okay, so if parse float, else if, because it'll never match, so it'll never do anything. It would just go through and whoop, back up to the top. So that's fine. Okay, so, and what is this like? I feel like string 0 and string 1, like these slices, there's gotta be a better way of doing this for strings. I wonder if we could just do like string, or we could do, what was it like? That would give us, well, this would be a regex match. I know, I shouldn't really do those. It makes everyone so angry. Actually, it just makes this one guy Sixstore angry. Maybe it's Kickstore? I don't know. Whatever it is, it makes him angry. So I'm now I'm trying not to use so many regexes. But yeah, and I'm like, I get the point, which is that regexes can be expensive to build. They're pretty fast once you've got them built to run them, but why would you use regexes when you can just do a string split? this is just looks ugly to me, just jinky. I don't know. Okay, so break on the C. Cool. This is fine. So subtree. What we can do, subtree. This is fine. Subtree and remainder, and then tree push subtree. So I don't know if this is much better than it used to be, but at least this function always returns the same object, which is down here, and we don't even need to return it. We can just return tree here. Cool. Tree remainder equals string. Yeah, so we're like changing tree to tree, we're adding to tree, and then we tack on this remainder. Okay, evaluate line, so we evaluate the parens, then the additions, then the multiplications. Yes, I know it's similar, and we turn the last remaining value, which is the answer, and this is evaluate. And then we reduce them together, and it passes all these things, and it gives us our answer. So cool. I'm good with that. I'm good to leave it there. It's time for my dinner. And what is the report? Allocation failed. JavaScript heap out of memory. Wow, that's incredible. I really fucked up Node real good this time. Hey, look, it's an Intel Core TM i7 CPU. I guess that's why I should get an M1 Mac. It's official. Okay. 1, 2, and input. Let's take a look at 1 again, see if there's anything in here. Let's run the file, 8006, and if we get rid of that, 8006, yeah, that was totally useless. Okay, and then return tree. Doesn't need to be return tree, we can just return the tree. And then evaluate line. I wonder if this evaluate line would work for that. Let's, it wouldn't, only because we don't want to evaluate the additions first, but otherwise it would probably, only because we don't want to evaluate the additions first, but otherwise it would probably work. We're just operating them no matter what. Cool, evaluate, and it still runs the same thing. Cool, input, assert that, yeah, good. Cool, I'm good with this. I'm out. That's it. I'm committing. Goodbye. Day 18 in the bag. Oh, and we should update the README. I don't remember the address of the first stream, but I have it written down. There we go. README. And that was day 18, so that's an offset of 17. And of course, the name of it, Operation Order. Sounds like an attack that we're planning. Get ready for Operation Order. Cool, admin of code 2020. We're good. So now we will add day 18 to README. And we're gonna push that up. Cool. Well, that was fun. Thanks anyone who is continuing to watch me fumble my way through computer stuff. One of these days, I'll learn how to write the softwares. In the meantime, thank you for sticking it out with me. Thank you for helping.